Welcome to ML Works. Today we'll be discussing few more aspects of computer vision. I've already posted a video on what getting started with computer vision, which is the part 1, and today we'll discuss few more things with respect to computer vision. And here are the topics we'll be covering today. First is filter. Next we'll talk about frequency. Next we'll talk about edge detection. This is not a theoretical video. Will be what implementing, going through a what notebook by a Jupyter notebook, and then we'll talk about Hough Transform. So first we'll just cover these 4 topics, what it means. Hough Transform. So what is frequency? Not frequency. First we'll start off with filter. So what is filter? So basically it means removing unwanted information. Okay, but there are also filters. Okay, filters are also known as kernels actually. Okay, let's be what reassure this. Okay, this one filter is also known as kernel. Okay, what we do is we remove unwanted information from our either from data, and here it means from images. Okay, so consider this is our image. Okay, and we have these pixel values. Okay, and we want to filter few information from this image. So what we do is we apply this filter. This filter, when it is applied, it will give us these values here. So it's by this what convolution operation. This operation is called as convolution operation. Multiplying what image with convolving with what kernel is called as this is the output we get, convolutions output. So what happens is 1 is multiplied with 1, 0, 1, and so here it is given. Okay, so what happens is 1 into 1 plus 1 into 0 plus, that is each this 1 and this 1 is multiplied, this 1 and 0 is multiplied, this 1 and 1 is multiplied, and all 3 are added. Again 0 is multiplied with 0, 1 is multiplied with 1, 0 is 1 is multiplied with 0. So this is what is done here also. Okay, so when it is addition is happening, we'll get all these values corresponding output. So this is what filters does actually. When you apply an filter, we remove unwanted information from data and images. So what is frequency? Frequency in terms of images. Frequency in images. So consider you have this black and white image with few grayscale in between, right? So here is the black part, here you have white, pure white, and here is the gray region. Okay, so any image, okay, which has this slow what changes with respect to intensity of the color, okay, it tends to have low frequency in the image, low frequency in image. And similarly, if you have an image like this one and consider it as like a darkened region is present, and you have another region is white, okay, this white region and changes drastically, right, to a black region, pure dark or white black. So there is a very drastic change in frequency. This is called as high frequency in images. High frequency in image. So this, in terms of what images, we can say it is rate of change of intensity. Rate of change of intensity. So where does this frequency helps actually? Okay, consider since we have this image, consider you have an image. Okay, yes, there is a black white background, a person is standing here. Okay, okay, so if we want to detect this person, so what we can do is first we can detect the edges of this person. So there is this drastic change that can be captured from this image. Okay, the person's what body and the background. So we can clearly create a edge detection here and separate out the person from the background. This can help us in what finding out the objects inside your images. So consider now once we do this edge detection, so we only have what, consider you have just edges present, you have detected these edges here, here and here, all these edges will be present. Okay, now with the help of this edge detection, what we can do is when we move forward with Hough transform, we can able to identify what is the shape of this edge detected, right? What is the shape of those things? Okay, so for that we comes to what we come to Hough transform. It tries to Hough transform is used for finding the shape, finding shape of your objects. We'll see that in the notebook. Okay, so we'll be covering what all these things in the notebook: filter, frequency, edge detection, and Hough transform. So let's move to notebooks now. Okay, so first we'll cover filters, what are frequencies, and then we'll look at few specific filters, and then we'll look at Hough transform. So what is filter first and foremost? So removing unwanted information. So once we remove unwanted information, we'll automatically have information which are relevant for us. Okay, so we'll be amplifying feature of interest or region of interest. So next we'll look at what is frequency in images, which is nothing but change in value of your pixel over a series of pixels, over a bunch of pixels. So this helps in what edge detection. So what is high frequency? High frequencies are nothing but images which have like sharp changes in the pixel value. Okay, from consider you have one pixel has 0 and the next pixel adjacent to it has 255. So there is a drastic change in value. So that leads to what high frequency. And there is something called as low frequency images. For example, if you have a bunch of what pixels like 100 pixels next to each other one after another in a grid, okay, the value changes from 0, 0 0.5, 1, 1.5 to 2.5. Okay, so these values, right, this low change in value of what pixel values leads to low frequency images. So the change in the intensity of the color is also slow. Okay, and the Fourier transform is one of the mathematical technique for what to perform analysis, to perform the analysis on the frequency characteristic of various filters. So let's take a look at Sobel filter. Sobel filter is used for edge detection. It also works by what calculating the change in the change or gradient of the image intensity at each pixel value. Okay, so first and foremost we'll be importing the packages. So what is the packages we are importing? First is the OpenCV. Next we'll import matplotlib, which is the visualization library, and then we have numpy, which is for numerical calculations like matrix multiplication. So first we import, this is the image we import. First is the lighthouse image we import, then we create a copy of that image and then turn it into what RGB format. So let's see. So this is the image. Next is we convert that image back to what grayscale. Okay, so this is the grayscale of the same image, and then what we do is we create our filter here. Filters are nothing but kernels. Kernels are nothing but matrix, 2D matrix or 3D matrix. Okay, so if you have worked in deep learning, there is like CNN convolutional neural networks. So what it does is here we have manually created a filter here. Okay, which will detect edges. So in deep learning what happens is we learn these kind of kernels, try to what identify patterns in your image like nose of the dog, okay, the whiskers in the cat. So all these kind of what learned from these kernels are learned in the CNN based neural networks. Okay, so here what we are doing is we are manually creating a filter here or a kernel. Okay, we are applying that using filter 2D function from CV2, which is OpenCV. Okay, we are applying that on top of our image, and what it will do is it will try to identify vertical. This is a vertical kernel, meaning it will try to what find vertical edges. Okay, and here we have something called as threshold. Threshold nothing but what it does is it tries to create a range. If you have a range, okay, if a value based on if a value in the image is matches with that range, it will try to take decision on top of it. So here what we are doing is we are applying what a threshold to convert it into threshold binary, meaning if any value in the image pixel value is greater than 100, it will be turned into dark, that is meaning 0, otherwise it will be 255. Okay, so here I'm running this cell now. So this is the so applying Sobel filter on top of the grayscale image. So this is the grayscale image we had, and we are applying a Sobel filter on top of it. So we are getting these what some values, some black and dark white, some spots we are getting. Okay, and also we have these lines here, right? We can see, which are nothing but the what edges you can consider, right? Because you have a dark at the back, and here you have this change in this gradient, right? This helps. This is what we get from what this vertical filter. Now, if you see here in creating binary image after applying Sobel filter, if you see all these dots, small dots are present, right? Which has value less than what, some has value less than 100, some has value greater than 100. The value greater than 100 are turned into what? Completely zero. Okay, we can see the difference between these two images, right? So it is either 0 or 255 here in this image. Okay, so we have different types of filters. First is high pass filter. What it will do is it will try to what, identify high frequency changes in your images. Then you have low pass filter, which does something what the high pass filter doesn't do, exactly opposite. So it smoothens your images and blocks high frequency parts of the images. And there is something also called as edge handling. These are some concepts which are related to what, how you are handling the features in your image which are present on the edge aspects, right? Either you can do some kind of what, padding, like adding more pixels to your image, or you can crop the image if required, if there is no relevant features on your edges, or you can what, extend the pixel values of your edge, whatever the feature is present at the edge, right? You can extend it the same feature, okay, by adding what, extend aspect of it. Okay, so these are some techniques which are not relevant right now for this what video. Okay, so these are some of the edge handling techniques. So gradient is nothing but, once again, it is change in what, intensity of your color in the image. Okay, and then we have what is noise. Noise are, you can consider these pickles, right? All these has noise. If you don't want to identify the, so consider this is your image, you want to identify windows in this image. Okay, so all these aspects are not important for this, right? You just want to what, identify these pattern, these vertical lines. Okay, these vertical lines. So that's what is your important feature, and all other features are considered as noise. These are called as specks or discoloration. Okay, so doesn't contain any useful information. So here we can read here, before applying high pass filter on an image, it's better to remove the noise from the image, because high pass filter exaggerate the image intensity. So what it means is, consider, okay, if we have this image and if we pass it through a high pass filter, okay, what will happen is this specks and this noise we see here, it will get exaggerated. Okay, so what we should do is, first we have to pass it through low pass filter, smoothen these images, and then we have to pass the high pass filter. Okay, so let's see here, applying the low pass filter to reduce the noise in the image by smoothening it. For smoothening means, what we need to do is we have to apply a low pass filter. Low pass filters are nothing but Gaussian blur is one of the low pass filter, and it will what, it is how it does this, it smoothens it or averaging the pixel point by surrounding pixel point values. Okay, so these are some techniques actually which we can go in depth, but right now it's not required. We'll just do it practically how it happens, right? So we'll see, once you apply what, Gaussian blur, that is low pass filter, is passed to the grayscale image, we see some, this images looks little smoothened actually. If we see here, right, let's see once again at the top. Yeah, we can see here clearly there are like few texture is present. Okay, texture is present, but once we apply the Gaussian blur, everything tends to what, smoothens out. Okay, we have some less specks or what, discoloration here, it's got reduced. Okay, so once that is done, when we apply the high pass filter over the low pass filter, after low pass filter, let's see what happens now. So now we can clearly see the number of the specks is got reduced, nothing is there, and we have these edges clearly, vertical lines, and here also we have these edges clearly mentioned. Okay, so now what we'll do is, again we'll try to what, create a what, threshold binary of on top of this image. Let's see what it looks like. Threshold binary. So consider why we are getting this image. So we have filtered image here, we are plotting what, black and white image, and this is the blur. This is the one we want to look at because this is the filtered image we are applying, right? Okay, so this is the one key aspect we want to look at. So here we don't have any specs right now. We just have what, two places where this vertical lines are present. Okay, here, and these vertical lines are present here. So it is not like perfect, but still we are able to what, identify there is something here and something here. Okay, let's see next. So we can see the noise in the image is reduced drastically after applying the low pass filter like Gaussian blur to reduce the noise, and then applying the filter like Sobel filter, which is an edge detector. Okay, so yeah, we can see that there is like lot of noise is reduced. Okay, so what we'll do is, this is what, using an Sobel filter we are doing the edge detection. Okay, now what we'll do is something called as Canny edge detection. This is also another method for what, performing edge detection. So here in OpenCV we already have what, a function called as Canny. Okay, so it will what, have these features. The series of steps is happening under the hood. First is applying the Gaussian blur, then applying Sobel filter, and then we are doing something called as non-maximum separation to identify the strong edges and thin them out to 1 pixel wide lines. Okay, then uses the hysteresis to isolate the best edges. So these are the series of steps which is happening under the hood when we apply dot canny operation on top of your image. Okay, so let's see what it looks like. Okay, here we are seeing like something, man, it's horrible actually. So let's see here what we are getting. So here we are not seeing anything specific we can understand here. So what we can do is applying Canny with wide and tight threshold. Let's see what it gives us. Okay, so when we pass it as wide Canny edge detection, it is trying to find whatever is possible, right? It is trying to get that. And tight edge detection, it is trying to get these edges actually. So let's see the what is the threshold they are using. 200 to 240, 60 to 100. Okay, so 80 to 160. Okay, so this is the same thing. This wide edge detection is the same thing which we saw here also. Okay, this is the wide edge detection, wide Canny edge detection. This is the tight. Okay, so let's see how it can. Okay, so here we are just getting what, some we have applied the same thing actually. We have done Sobel filter. So here what we are trying to do is we are applying the Canny edge detection using what, already pre-built function Canny. Okay, so here also we get these kind of what, specific aspects of each images we can get. Now what we'll do is consider we have what, a very good image with where we have perfect edge detection is happening. So now once we get the edge detection, we have to capture that whole content where the edges is present, right? So for that we have something called as Hough Transform. So if you are seeing here, right, after finding edges, it is obvious that we have to find the object which is encapsulated by the edges. So Hough Transform helps in transforming the image data from XY coordinate system into Hough space. So what it will do, right? So it will, if you have what, a line, right, on your XY. Okay, XY, if you have some XY graph. Okay, so there is a line. Okay, so this line will turn into what, an XY coordinate is turned into a point when it is transformed to Hough transform. This is called as Hough space. In Hough space it will become a point. Okay, so this is Hough transform is used for shape recognition application. So let's see. So here it is given actually, line equation ymx plus c is equal to is converted into a point in Hough space. So that's what it does actually. So let's try to apply. Here we have lighthouse image, then we are trying to what, turn it into grayscale, and then we are doing Canny edge detection. So this is what, this is the tight Canny edge detection we are doing here. That's why we don't have a lot of noise here compared to this one. Okay, so we have less noise here, and let's see what is happening in Hough line detection. So Hough line detection we have, there is also something called as Hough circle detection. So here, since this is the vertical edge we have to find out, so we are doing like Hough line detection. Okay, let's see how it does. So this is the function we are using here. Okay, and then once we are able to what identify all the lines, we are iterating through each line here, and then we are plotting it on top of that image. Okay, with red color. This is the red color we are passing here. Okay, so this is the edge detection that is happening. You can clearly see, right? Though it is missing this aspect, I'm not sure why. Okay, but it's not. We can what experiment with these things like these values, right? We can experiment with that. Let's see, like 300. Let's see what happens. I don't see much change. Okay, let's see 30. So this is gone. We are not seeing that edge here now. So it's better to increase the value. Oh, 150. Okay, we are seeing some much better. Okay, this edge is detected again. This edge is again back. Okay, okay. Let's see. Let's see. Okay, so we can what by keeping what keep on changing this threshold, we can find some value, optimal value, where you can get a better aspect of your edges here. So now what we have done is we have applied what Hough line detection on top of your grayscale image or your image. We have applied that and we try to plot that one, this line detection. Now what we'll do is we'll try to apply the same on circles. So what we'll do is we import one image which is again turned into what RGB, and then we also have gray scale image of that same image. Let's see how it looks like. So this is the image we have. Okay, these are a bunch of coins we present. Okay, next what we do is we are doing Canny edge detection on top of this. Okay, which is not perfect. Okay, so it is giving us some, yeah, edges is present, circle is present, we have all these things present here. Now what we'll do is on top of this we'll be trying to what extract the shape out of these images. So these are present in circle shape, so we have to identify these things. So what we do is first we apply median blur. What median blur does is it tries to what smoothens out your what image such that it does not identify false positives, like false circles it should not identify. That's why we do median blur here. And then we are what iterating through this rows we have, right? We are iterating and we are just what trying to identify circles from the image based on these bunch of parameters. Okay, this is here also we have to understand, like we are applying what this Canny edge detection under the hood, right? There is Canny edge detection is happening here, and then we are also what once the edge detection is done, then we are applying this Hough gradient, and then we are getting our circles. And once we get the circles, we iterate through these circles, and then we plot our what edges on top of our images. Let's see how it looks. Okay, we have done our this Hough transform on top of this, and then we can see our circles on our objects, Hough circles. So it is missing two of these points. Let's see if we can improve. So as we saw, right, earlier Sobel filter gave us a better result actually we compare to our Canny edge detection. So what I'll do is I'll just here I'm applying what on top of Canny image, right? I'm applying. So I'll do it into what for grayscale image I'll do now on grayscale, because I've noticed some changes when I tried right earlier. There are some changes I have seen. Okay, so when I apply it on top of grayscale image, it is performing better. Okay, so this thing, this whatever the edge detection happened here while applying this function is better actually compared to applying on the images which already underwent Canny edge detection. So what I mean is Canny edge detection from Hough transform is better than just applying Canny edge detection and then Hough transform, because Hough transform basically it has this what already has this function of Canny edge detection. So if you let's just see this one again actually, Hough circles, right? Hough circles, if I go Hough Transform, I'll just go to Hough Transform. Let's see what we have. Oh, let's see, to open CV. Open CV. Okay. Let's see. So yeah, so if we go here, we can notice something used for, okay, line detection is a transform used to detect straight lines. To apply transform, first edge detection pre-processing is desirable. Okay, it is desirable. Okay, so edge detection is desirable here, it's given. So let's go to that function for a moment. Here if we go, so we are reading half lines. So here the different set of parameters are present actually. Okay, let's see here what we have in py. Okay, Canny. So here also they are applying Canny edge detection on top of it, like outside they are applying. Okay, and then they are applying half lines on top of it. Okay, let's see. Half circles. Okay, half circles, right? Let's see half circles. So if we see here, half circle transform is okay. The line detection, okay. So median blur, so param 1 and param 2 it's given. So if you want to understand this thing, param 1 and param 2, it gives here like upper threshold for the internal Canny edge detector. So this is what the parameters refers to actually. Okay, this applies actually, edge detection is happening inside what Hough transform itself, Hough circles here. Okay, so we have seen a bunch of stuff in this video now. First, we saw filters. What is Sobel filter? It's a manual filter which we create, okay, and then we apply it on top of our image. And there are like bunch of issues with how we apply. Like a lot of noise is present. So what we do is first we pass it through low pass filter and then we pass it through high pass filter such that the noise is reduced. And then we talk about something called as Canny detection, which is available in OpenCV. Then we talk about Hough transform for what? Creating a perfect encapsulation of your objects in your image. Okay, so we are almost done with this video. So in the next video, I'll be talking about what? The part 3 of the computer vision basics. Okay, thank you.